Yes. Uh, all right. Please pay attention, everyone. Silence, please. No discussion at the back. So in the previous class, we have seen LR method, and in the LR method, we have taken a 2 by 2 matrix. Okay. Today we are going to study the same method, but this time we are going for a 3 by 3 matrix. So the number of calculations involved, they will be slightly more. Okay. So still, I have chosen a problem in such a way that you will get solution probably after 2 or 3 iterations only. Okay, so that your calculations can be reduced. Okay, otherwise, if it is a 3 by 3 matrix, in that case, you have to go maximum up to 9 iterations. Okay, but in this problem, you may be getting the solution probably after 2 or 3 iterations. Okay, so your problem is like this. Let me note it down on the screen. So you need to find out the eigenvalues of a matrix. It is like 2, 0, then -1. This is 0, 2, and 0. This is -1, 0, and 2. Okay. Now in the LR method, what exactly we are doing? Anyone? So we are doing some operations, and then we are converting the given matrix into upper triangular matrix. Okay. So if you see the actual problem, it is more or less a upper triangular matrix, because in the lower triangle there are 3 elements, out of which 2 are already 0, isn't it? There is only one element which is -1, which is at the location of third row and first column. Okay, so by looking at the matrix, you can say yes, this is a relatively less amount of work. Okay, so now in LR method, what exactly we are doing? We are breaking the given matrix into 2 parts. One is the lower triangular matrix, and one is the upper triangular matrix. Okay, such that if you multiply them, you should be getting the original matrix back. So I'm assuming this is your matrix number A. So this matrix A has to be divided into 2 parts. One is L and second one is U. I'm calling this as L1 and U1. Okay, so this L1 and U1, so it will be having a form something like this. So L is basically 1, 0, 0. This is L21, 1 and 0. This is L31, L32 and 0. So this is your lower triangular matrix. And if you multiply it with the upper triangular matrix, which is U11, U12, U13, this will be 0, U22, U23, this will be 0, this will be 0, and this will be U33. Okay, so if you multiply this, you should get the original matrix back, that is 2, 0, -1, and 0, 2, 0, and this is -1, 0, and 2. Okay, so one by one, sorry. Oh, sorry. This should be 1. Okay, thank you. So if you do the calculations, you will get the unknowns, that is 3 values in the lower triangular matrix and 6 values in the upper triangular matrix. So you can directly write down these values same as your uh, original matrix. So this value should be 2, this value should be 0, and this value should be -1. Okay, so your work is reduced. So now I want all of you to give me the value of L21, 31, 32 and U22, 23 and 33. Do it fast, everybody. Yes, please do it fast. Everybody, please do the calculations. Any queries? Yes, anyone got the answer? बराबर है? So most of the terms are 0, 0, 0 only. है ना? So basically, after doing all these operations, you should get the L matrix. Okay. So this will be your lower triangular matrix. So I'm going to call this as L1. So L1 should be 1, 0, and 0. This will be 0, 1, and 0. This will be minus 0.5, 0, and 1. Okay. And your U1 matrix will be something like 2, 0, minus 1. Of course, these two will be 0. This is 0. Sorry, this is 2, this is 0. This will be 0, and this is 1.5. Okay? So basically, if you multiply L1 with U1, you should get your original matrix A back. Okay? But now, from this A, now you have to generate A1. Okay, the A1 will be the product of U1 and then L1. Okay, so if you write this, so U matrix will be something like 2, 0, minus 1, 0, 2, and 0. This is 0, 0, 1.5 multiplied by you have 1, 0, 0, 0, 1, 0. This is minus 0.5, 0, and 1. Okay, just take a product of this and give me the values. Are you getting this? Yes, are you getting this? तुम्हारे कैलकुलेटर में मैट्रिक्स मल्टीप्लिकेशन का ऑप्शन रहता है ना, फटाफट डालो. Getting it? Okay. Shall I continue? So basically, this matrix, this matrix is nothing but your A1 matrix. Okay. So now you look at your A1 matrix. It is not a upper triangular matrix. Okay. There is still one element which is non-zero in the lower triangle. So in this case, you have to go for one more cycle. So you have now this A1 matrix. Okay. So now again, you have to break this A1 matrix into a lower triangular matrix and into a upper triangular matrix. So I'm calling this as L2 and U2. Okay. So I'm writing the lower triangular matrix one more time. So this is 1 0 0. This is L 2 1 1 and 0. L 3 1, L 3 2 and 0. So this is the lower triangular matrix. This has to be taken with U11, U12, U13 0, U22, U23 0 0 and U33. This should be equal to something like 2.5, 0, minus 1, 0 to 0. This is minus 0.75, 0 and 1.5. Okay. So you can directly write down the first row of the upper triangular matrix because it is going to remain same. So this will be 2.5, this will be 0 and this will be minus 1. Okay. So please do the calculations and give me the values of other 6 unknowns. Please check whether you are getting these answers or not. I have already written the answers. All right. So the lower triangle should be like 0, minus 0.3 and 0. in the upper triangle 2.50 minus 1, then 0 and 2 and 0, and then 1.2. आ रहा है? सही में आ रहा है कि गलत हो रहा है कुछ? 3 वाला is 1.2. I am getting 1.2. I am getting 1.2. Please check your calculations. So I don't know if it is not visible to you. Please check, because you see here, if you take the multiplication of last row and the last column, okay, so it is minus 0.3 into minus 1. ठीक है? So that comes out to be 0.15. बराबर है? सॉरी 0.3, हाँ, प्लस 0.3 आएगा, और ये आएगा तुम्हारा दिस इंटू दिस, सॉरी, तो ये 1 पॉइंट, अच्छा, अरे यार ये मैंने गलत लिखा है, रुको, दिस शुड बी 1 ना. Okay, now is it okay? Because lower triangle the diagonal is 1, right? So now I hope this is matching. Okay, so basically after the second cycle you got values of lower triangle which are like this, so I'll be calling this as L2. Okay, so your L2 will look like this, that is 1 0 0 0 1 0. This will be minus 0.3 0 and 1. At the same time the value of U2 will be, this will be 2.5 0 minus 1. These two are already 0, this is 2 and 0, this will be also 0, this will be just 1.2. So you see we are just playing with only some of the elements, rest of the elements are already 0. Okay, so now if you see, we have started with A and we have generated A1. So now from A1, now I am going to generate A2. So A2 क्या रहेगा? A2 will be the product of U2 with L2. बराबर है? Okay. So here, let me write down. So your U2, so U2 is, this is 2.50 and 0, this is 0 to 0, this is minus 1 0 and 1.2 multiplied by, you have now L2, that is 1 0 and 0, this is 0 1 and 0, this is minus 0.3 0 and 1. So you should get another matrix which we will be calling as A2. Okay, please do the calculations. You can use your calculators. Okay. Are you getting this? Yes. Are you getting this A2 value? Okay. So again, you see, this is still not converted into a upper triangular matrix. Okay. because the lower triangle is already 0. Okay, so I'm just saving your lot of calculations. I'm completing the problem here itself. Let me show you the screen. Okay, so here I have already developed a program, and with which I can easily get the answers. Okay, so it is slightly, the font is very low because it is in DOS. So after the second iteration, I am getting the matrix which I have already written. Okay, but if I go for one more iteration, that is one more trial, in that case the things are changing. Okay, so let me put it on the screen with some bigger picture. I hope this is visible now. Okay, so after the second trial, you should get the lower triangular matrix, which is something like this, upper triangular matrix, something like this, and your A matrix. So for the first time, you will see the diagonal element which is there, 1, 1. It is coming closer to 2.92, so it is coming closer to 3. Okay, and then the second diagonal is 2 and third diagonal is 1.03, and you can see the lower triangle is almost 0 now. Okay, only one element is there non-zero, that is minus 0.137755. Okay, so this is how uh, one cycle is going to give you the results. Let me go for one more trial. Okay, so if you go for one more trial, so it will look like this. Okay, so after this, shall I complete this? So if you go for many trials, you should get the final answer. So after many trials, the last value, okay, I'm just putting the last value on the screen. Okay, so these are the results after the ninth iteration. Okay, so you can see the diagonal element is now 2.999, which is almost 3. The second diagonal element is 2, and the third diagonal element is 1.00 something. Okay, so here you can see this part is almost becoming 0, that is 0.0002. So basically the original matrix A is now converted into upper triangular matrix. So after 9 cycle, you are getting the eigenvalues as 3, that is 2.999. So we can say it 3 because in computer there are round of errors. That's why it is getting 2.99. Ideally it is 3. So it is getting 3, 2 and 1. Okay. So this is how the LR method is going to work. So if you want, you can solve the same problem using the direct method. I'm sure you'll be getting the values like 3, 2 and 1 are the eigenvalues. Okay? Matrix is very, very simple. Okay, you can do it manually also. It's very simple. Okay? So with this, I'm completing this particular topic. I won't be taking more examples on this. Okay? Because topic I'm assuming that everybody has understood this. Okay, we have already covered 2 by 2 matrix. We have also covered a 3 by 3 matrix. Like I said earlier, 3 by 3 matrix involves a lot of calculations. It won't be asked in your examination. Okay, mostly it will be there in form of a 2 by 2. Even if it is asked in the examination as 3 by 3 matrix, you are supposed to do at least 2 iterations, not more than 2 iterations. Okay, because otherwise the 1 hour or maybe more than that will be consumed in your calculation part. Okay, so we'll stop now and let me quickly take your attendance.